How do we power our world? It's probably one of the biggest, most important questions of our time. So in this explainer, we're going to take a journey all the way from the fossil fuels that, let's be honest, built our modern society to the incredible new technologies that are completely redefining our future. Let's dive in.
So, first things first, where does our power actually come from? Well, take a look. This is our planet's energy diet. And you can see right away the biggest pieces of the pie are oil, coal, and natural gas. These fossil fuels have powered our growth for centuries, but they absolutely come at a cost. So the real question is this diet sustainable?
All right, here's our game plan. We'll start by looking at our current energy addiction. Then we're going to face the music and look at the true cost of that dependency. After that, things get more hopeful. We'll explore the rise of renewables, see how AI is basically supercharging the whole thing, and finally, look at the path to a greener future. So, let's kick things off with where we are right now. Because look, to figure out where we're going, we first have to get a really clear picture of the system we've built, this deep, global reliance on what we call conventional energy. So, what do we even mean by conventional energy? Well, you know them well. Coal, petroleum, natural gas. These are the sources we've been using for a very long time. But the most important thing to remember here is that they're finite. There's only so much in the ground. Once we use them, they're gone. They are, by definition, non-renewable.
And this chart, wow, it really drives home the scale of our dependency. Just look at that. Oil, coal, and natural gas together are the lion's share of everything we consume. Everything else, solar, wind, hydro, nuclear, it's all squeezed into that much smaller other slice. This, right here, is the addiction we need to talk about.
But of course, this heavy reliance comes with a very, very heavy price. So now we're going to get real and look at the true environmental cost of our fossil fuel habit, a bill that has been piling up for generations. What's so interesting here is how clearly this table draws the battle lines. On one side, conventional sources, old technology, a major cause of pollution, and they run out. On the other side, non-conventional sources, newer, clean to use, and for the most part, they never run out. The difference couldn't be starker. So let's break down the actual damage. Burning fossil fuels, number one, releases enormous amounts of CO2, which drives global warming. As we've said, they're a finite resource. They also contribute to things like acid rain. And the human cost, it's huge, from all the respiratory illnesses caused by air pollution to horrible diseases like black lung that coal miners have faced for years.
And believe me, the damage doesn't stop there. The entire life cycle of fossil fuels is destructive. Strip mining for coal can literally remove mountaintops, destroying whole ecosystems forever. Oil spills, runoff, they cause devastating water pollution. And beyond CO2, burning this stuff fills our air with smog and soot. Oh, and our oceans? They absorb about a quarter of our carbon emissions, which makes them more acidic and threatens all sorts of marine life.
Okay, that was a lot of doom and gloom, I know. But here's the pivot. For every problem, there's a potential solution. And in the world of energy, that solution is the incredible, unstoppable rise of renewable resources.
And the core idea here is actually really simple and beautiful. Renewable energy comes from sources that are, for all practical purposes, inexhaustible. The sun is going to keep shining, right? The wind is going to keep blowing. And the best part is we can harness all this power without releasing the pollutants that are damaging our planet.
So, who are the MVPs on this clean energy team? All right, let's meet the powerhouses that are leading the charge.
First up, the big one, solar energy. It's the most abundant energy resource on Earth, period. We can tap into the sun's radiation and turn it directly into electricity or use it for heat. It's so often called the most promising path forward, and honestly, for very good reason. Next up, wind energy. And what is wind, really? It's basically just a side effect of the sun heating our atmosphere unevenly. We just use these massive, elegant turbines to capture the energy of that moving air and turn it into clean, reliable electricity.
And we can't forget geothermal. This is literally energy from the inside out. We're tapping into the incredible heat that's stored deep inside the Earth's core. We use that heat to create steam, spin turbines, and generate electricity around the clock, 24/7, no matter what the weather's doing outside.
So, when you put it all together, the advantages are pretty clear. Renewables are inexhaustible and they're safe for the environment. Once you build them, their running costs are super low. And because you can build them almost anywhere, they can bring power to remote communities that have never had it before. That's a huge deal. So we have the problem, fossil fuels, and we have the solution, renewables. But how do we speed up the switch? Well, this is where our story takes a really fascinating futuristic turn with a game-changing catalyst, artificial intelligence.
This quote from AI for Our Planet just nails it. AI is the bridge. It solves the single biggest challenge with renewables, their unpredictable nature. It helps us match that up and down supply with our constant demand for energy. It's the key that unlocks their true potential. And here it is, the million-dollar question. This is what's historically held renewables back. It's called intermittency. You're probably thinking it, right? What happens on a cloudy day or a calm day? Power grids need a stable, predictable supply. So, how do we solve for that?
Well, this is how. AI basically becomes the brain of the power grid. First, it forecasts. It uses tons of weather data to predict, say, a cloud bank is about to reduce solar power in Arizona, while at the same time, it sees a huge wind surge coming to Texas. Second, it balances. It starts rerouting that Texas wind power to cover the Arizona dip before it even happens. And third, it optimizes the whole system, cutting waste and making our grid stronger and more efficient than ever.
And AI's role goes even deeper. It can predict when a specific part on a wind turbine is about to fail before it breaks, saving millions in repair costs. It analyzes usage patterns to help big factories use less energy. It's the absolute core of the smart grid, a system that intelligently manages energy flow to boost efficiency and slash emissions.
So, we have the tools, we have the tech. Let's wrap up by looking at the path forward and the very real progress that's already being made out there.
And the progress is actually stunning. This isn't some far-off dream. It is happening right now. Check this out. In 2022, nearly 70% of all new power capacity added around the world came from renewables. That signals a massive shift in where the money and the effort are going. The transition isn't just happening, it's speeding up.
And that leaves us with one final, crucial question. We know where we need to go, a sustainable energy future. We have the vehicles to get us there, renewable energy. And we have an incredible navigation system in artificial intelligence. The question for all of us is, can we put these pieces together fast enough? The answer is going to define the world we leave behind. Thanks for joining this explainer.